welcome everybody from the West Coast. And I would like to actually talk a little bit about a different aspect within the context of communications, which is the compute aspect. And I thank all the previous speakers in this track to have actually supported my key message here, which is let's not just look at spectrum only and wireless only. Next year will be about much more. And at the end, I would like to give a little bit of a highlight on what we are building here at VMware with other partners. So looking at the previous generations, what do we see? And believe me, it won't be a G history talk here, but what I wanted to highlight here is actually we are acting as if cloud just comes with NextG or softwareization, virtualization came only with 5G with current thoughts. But what we have seen over the generations is that some of the foundations have been laid in previous generations and then realized in current succeeding generations. And in 4G, we have introduced self-organizing networks. The term SON has been mentioned, where we already started to work on ML-based solutions. We have started to introduce more softwareization. In 5G, we started looking into machine type communications, the so-called verticals. We introduced the edge, so more compute, starring, acting, and sensing was introduced. But with 6G, we want to harmonize all of this. We want to make solutions more native, cloud native, AI native, our terminologies that are felt. And the focus here will be on the human and human needs, whereas in 5G today, we were looking into how can we make machines communicate with us or with each other. Now, looking at some technologies that are objectives that we see within the context of NXG, and this is by far means not a comprehensive list, just a few examples. We are talking about digital world experiences, which is coming with the within the context of MR or XR, and people who know me know that I have been working almost since a decade now on the tactile internet, which enables us to have remote physical interaction with digital and physical objects falling also into this. I mentioned cloud native solutions, programmable networks are discussed in this context, sensing as well as machine learning concepts, also to enable ubiquitous compute and connectivity in a distributed manner, because we're talking about highly heterogeneous networks and highly heterogeneous data centers, which requires distribution. Energy efficiency and sustainability, green G is a big term, and we have heard in this track multiple times, security and resiliency. Again, this is not a comprehensive list, just a few examples to give you the diversity of the technology objectives that are discussed within the NextG context. And how do we want to get there? Because these are big challenges. By actually looking into the evolution of multiple technologies simultaneously, monetizing them, accessing them, as well as contributing to them. Radio is evolving, as we know, with the Gs, but a medium is evolving. You had these intelligent surfaces discussion here. The CAI is evolving. The internet itself is evolving. Compute, data, web, every individual technology is actually evolving, some in parallel, some orthogonal to each other, some quite complementary to each other. And to make these technology objectives in NextG real, we have to benefit from these evolutions and be aware of these evolutions. Let's look into how compute evolved. And to my actually also own surprise, I have seen that computers have also 5 generations. So they're also in their 5G. Starting with a very primitive vacuum tube-based first generations in the early 40s, and then transistor-based solutions, integrated circuit-based solutions, microprocessors, which are still today's computers, but we have also heard just in a previous talk that quantum is emerging and AI-based solutions are coming up. And it is really amazing to see that in actually within 80 years that from nothing to every individual's pockets, computers emerged. So they went also, the computer world went also through their generations and evolutions. And to look a little bit into how this evolved, in the 30s or 40s, the idea was to have computerless there were computerless computers because it was just a theoretical technology and nothing was there yet. In the 60s and 70s, mainframe computing was introduced, meaning we had huge data centers, massive computers in one physical locations, and only a few people, mainly from military or governments, were able to access them. In the 80s and 90s, we experienced desktop computing. Offices had intranets where we could access information, and it was typically for business applications, but some of us had also their first computers at their homes. In the 2000s, we started with ubiquitous computing to share information, access information, also in a mobile manner, and computers just try to slowly also disappear with the emergence of cloud. Not only we can access compute from an individual device, but now with cloud services, multiple of us can actually access virtual computers in a cloud environment simultaneously. But to realize this and make the full benefit of this, there are still many challenges ahead. On the other hand, cloud was evolving. I will not go through all of these, but you can see cloud actually started in the 2000s with the virtualization itself. And it is basically just 2 decades old, went through a very long phase of 40 years with nothing has happened, although there was a concept of software as a service as an idea, but only in the 2000s, early 2000s, with virtualization and infrastructure as a service or platform as a service solutions, we were able to get to the point where we are today, and hopefully get to cloud native solutions in the near future everywhere. If we talk now about cloud, cloud is deployed in different manners. There are private clouds that individuals or groups of individuals have access to. There are public clouds such as Google's, Amazon cloud services that every individual of us can basically purchase per time. And there are hybrid clouds, which are the combination of those, and multi-cloud solutions, which are essential also for us in NextG, because we will have multiple data centers and multiple edges, as we see. But in the cloud deployment themselves, there are several challenges ahead: governance, compliance, security, interoperability, data portability, etc., etc. The web is evolving as well, from just being available for read-only content to social media and interactive services today, and semantic web in the context of Web 3.0 or blockchain. And AI is evolving. So AI started in the 50s with John McCarthy, who is actually known as the founder of AI, who introduced the term intelligence in 1955, and Turing suggested at similar times, if humans use available information as well as reason to solve problems, to make decisions, then why can't this be done also by machines? And he introduced basically the idea of machine learning in that context. But until the 80s, actually not much happened in the AI research. In 80s, there was a wave coming up with a lot of funding. However, with nowadays, actually in the early 2000s, we see a huge increase also in respect to AI research, from maybe starting with very narrow intelligence that is limited in its scope, with intelligence restricted to only one functional area, to more general intelligence, that covers more than one field, like power of reasoning, problem solving, abstract thinking, etc., to where AI scientists want to go to super intelligence, basically also outperforms humans. And all this, while all this evolves, we do believe that also humans evolve because we are adapting to technology and make them into an integral part and seamless part of our everyday lives. And in future, we should basically benefit for that and create something that we call the evolution continuum. Why we as humans, the society and their needs evolve, technology should develop solutions that can be transferred and applied to human needs. And what do we do to make this happen for everyone in the scale, for providing planet scale solutions? We are building the grid, something that we call the grid. As a very first solution of this, we have basically built the multi-cloud services grid, which is industry first multi-sector offering that basically strings together heterogeneous resources from wireless, cloud, and internet providers for enabling something that we called hyper-composed applications. And what do I mean with this? Those are applications that are dynamically composed with the, now I hope my animation will work, right type of resources in the right amount, at the right place, at the right time, and with continuous and intelligent optimization across all these 4 dimensions. That's what the grid is supposed to enable at a global scale. And for this, we have launched, founded the Open Grid Alliance with more than 30 industrial members, where we are having different work streams, the think tank, tackling the fundamental problems and identifying these problems for the grid, and NextG, the innovation zone, where we have actually this multi-cloud services grid in physical environments and labs built and developed. And we would like to create basically a society that facilitates collaboration around multi-dimensional thinking. And with that, I would like to offer you, please reach out to me if you want to know more about any of these research activities or hands-on activities. And thank you all for your time and interest and attention.